On numbers 25 through 29, you're told to refer to circle B, which again means point B is the center, and you have a radius BP. So we could have told that without being told that, but they're just making sure you understand that BP is a radius. So on number 25, it gives you the length of BP to be 4. So that tells me that every radius in that circle is going to be 4. And by the way, this drawing is used for all of these, but they're not building on one another. So I went ahead and made that figure 3 different times for us to look at the different problems. So number 25, if BP is 4 units long, it wants to know the length of SP, which is the whole diameter. So since all radii are congruent, we know B to S would also be 4. So the whole length of the diameter is just 4 plus 4, which is 8. Number 26 is a separate problem, same drawing. This time it gives you the length of SP, which is the diameter, to be 16N. So we're wanting to know what BP is, which is the radius. So we know the radius is just half of the diameter, so we just need half of that 16N. Since half of 16 is 8, the radius would be 8N. Number 27 tells us if line PQ, which we don't have arrows here, so for it to be a line we would really have to have arrows at the end, is tangent to circle B, then we want to know what the measure of angle BPQ is. So BPQ is this angle that you're trying to determine what it is right here. Well, since the diameter is going to the point of tangency, remember we learned a theorem that says that that radius drawn to the point of tangency creates a perpendicular relationship. And so this would be a 90-degree angle for BPQ. Number 28 says if PQ and RQ are both tangent to circle B, so again, we really need arrows on the end here to call that a line, then we're wanting to know what would be congruent. Well, we learned that if you have 2 tangents drawn to the same circle from the same external point, which would be point Q where they intersect, then those tangents have to be congruent to each other. Now remember, we can't say lines are congruent because we can't measure a line, so we're really only talking about the segment from the point of intersection to the point of tangency. So we're talking about this segment, which is segment RQ, being congruent to this segment from P to Q, or segment PQ. Now remember, you need those segment bars. You can't just say RQ is congruent to PQ, because remember, these represent numbers, and numbers can't be congruent. Numbers are equal. We're talking about the figures, the segments that are congruent to each other. So you need to have those segment bars above RQ and PQ. On 29, again, if RQ is a tangent to circle B, then segment BR is not even drawn in the figure, but this is what it's talking about, would have what relationship to line RQ? So again, it's the same relationship we just talked about in 27. If you have a radius drawn to a point of tangency, you create a right angle, but we wouldn't say would be a right angle to a line. That wouldn't make sense. The word here is perpendicular. The radius is perpendicular to the tangent line.